Today we're going to prove that the area of a circle is equal to r squared times pi by using limits. But first of all, let's take a look at this hexagon. We can divide this hexagon into 6 congruent triangles, and we can say that the area of the hexagon is equal to 6, that is the number of triangles, times the area of a single triangle. And we can generalize this formula to any polygon, and we can say that the area of any polygon is equal to n times a, where n is the number of sides of the polygon. That is also the number of triangles. Okay, now let's take a closer look to a single triangle. I've called this distance r and this angle theta. So we know that the area of any triangle is equal to base times height, or divided by 2, right? In this case, the base is this segment right here. So we know that base is equal to r, and the height is this segment here. And we know that h is equal to r sine of theta, since this side and this side of the triangles are equal. So this is also r. Okay, so we can substitute the base and the height in this formula, and we get that the area of the triangle is equal to the base, that is r, times the height, that is r times sine of theta, or divided by 2. And we finally get that the area of a single triangle is equal to r squared divided by 2 times the sine of theta. Okay, now that we have these equations for the area of a single triangle, we can substitute this into our previous equation. So we get that the area of any polygon is equal to n times r squared divided by 2 times sine of theta. Now we want this value n as a function of theta. Is the number of triangles, so also the number of angles. And since it is also the number of angles, we can write that theta is equal to 2 pi over n. 2 pi radians is equal to 360 degrees, right? So we are just saying that the angle theta is 360 degrees divided by n times. Okay, so we know that the area of any polygon is equal to 2 pi over theta, because now in this formula we get that n is equal to 2 pi over theta times r squared divided by 2 times sine of theta. We can cancel out 2 and 2, and we finally get that the area of any polygon is equal to r squared times pi times sine of theta over theta. Now you might ask, why have we done all of this? Well, because we can represent the area of a circle as the sum of an infinite amount of little triangles, where you notice the angle theta approaches 0. So, what is the area of a circle? Well, the area of a circle is equal to the limit as theta approaches 0 of r squared times pi times sine of theta over theta. And since r squared and pi are constants, this is equal to r squared times pi times the limit as theta approaches 0 of sine of theta over theta. Now we have just to evaluate this limit right here. And as you probably recognized, this is a very famous limit. And we can do it by putting down some inequality by the squeeze theorem. So we know that sine of theta is less or equal to theta that is less or equal to the tangent of theta. So we know that 1 over the sine of theta is greater or equal to, because we have to flip the inequality, 1 over theta that is greater or equal to the cosine of theta over the sine of theta. Now we want sine of theta over theta here in the middle. So what we can do? Well, we multiply everything by sine of theta. So we get that 1 is greater or equal to sine of theta over theta. That is greater or equal to cosine theta, right? Now we have to take the limits as theta approaches 0 from the plus side. So limit as theta approaches 0 plus, the limit as theta approaches 0 plus, and the limit as theta approaches 0 plus. The limit as theta approaches 0 plus 1 is 1, is greater or equal to the limit that we have to evaluate. That is greater or equal to the limit as theta approaches 0 plus of cosine theta is 1. So we know that this limit must be equal to 1. So now that we have the limit as theta approaches 0 plus of sine of theta over theta, we can do the same thing, but from the minus side. So we have to flip the inequality and we get the limit as theta approaches 0 minus of sine of theta over theta is equal to 1. So the limit as theta approaches 0 of sine of theta over theta exists and is equal to 1. And we have finally proven that the area of a circle is equal to r squared times pi. If you enjoyed my videos, please subscribe to my channel, leave it a thumbs up and share this video with your friends. Until next time, bye.